Hello, today we're going to start a new chapter, chapter 7, additional topics in integration. In chapter 6, we introduced the integration and we discussed some basic rules for integration. All of them have the correspondence from differentiation rules. And it turns out it's much more difficult to integrate than to differentiate. In many cases, you might need to seek for some special techniques, and the integrating by parts is just one of those techniques. So let's talk about the integrating by parts in 7.1. If you still remember the product rule for differentiation, it says the derivative of product of two functions u and v is equal to u prime v plus uv prime. If you integrate on both sides, you get the uv on the left, and you get two integrals on the right, which are u prime v dx and the uv prime dx. You can rearrange the terms in each integral to get the v times u prime dx and u times v prime dx. Now, using the definition of differentiation, we get the u prime dx is just du, and v prime dx is just dv. So we can rewrite the formula as uv equals the integral of v du plus the integral of u dv. So we write in the formula by arranging the terms to get the integral of u dv equals uv minus the integral of v du. So what's the point? The point is the integral of u dv might hard to integrate. Then you try to carry out another integral v du on the right and get the answer. The key here is to identify the u and dv in the original problem because they are not specified in the problem itself. So let's do some examples. Find the indefinite integral of x times e to the x. You cannot find the antiderivative of this function from the formulas. So let's try the method of integrating by parts. Let u equal to x and dv equal to e to the x dx. Okay, so then you take the differential of u, you get u prime dx, which is x prime dx, or 1 dx, that's just dx. And we know dv is just v prime dx. But in this problem, dv is e to the x dx, so v prime is just e to the x. So you integrate the e to the x, we get the v equal to e to the x. So now use the method of integration by parts. We get the integral of x e to the x, or u dv, equals uv minus integral of v du. Plug in u, v, and du. We got the x times e to the x minus the integral of e to the x. So the final answer is just x e to the x minus e to the x plus c. Now let's do another problem by evaluating the definite integral. So evaluate the definite integral of x times ln x from 1 to 2 by using the method of integration by parts. So again, we need to identify a good choice for u. So this time we let u equal to ln x and dv equal to x dx. So take the differential of u, we get u prime dx over ln x prime dx, which is 1 over x dx. And again, dv equals v prime dx, and this problem dv is x dx. So v prime equal to x, and we integrate the x to get v, which is 1/2 x squared. So now using the formula for integrating by parts, we get the integral of x ln x from 1 to 2 equals u dv from 1 to 2, which is uv minus the integral of v du. So that's just the ln x times 1/2 x squared minus the integral of 1/2 x squared times 1 over x dx if you plug in u, v, and du. Now, the second term can be simplified as negative half of integral of x, and that can be easily integrated to get 1/2 x squared ln x minus 1/2 times 1/2 x squared. So that's just 1/2 x squared ln x minus 1/4 x squared. Now plug in 2 and 1 for x and subtract, we get 1/2 2 squared and 2 minus 1/4 2 squared minus 1/2 times 1 squared and 1 minus 1/4 times 1 squared. And we know ln1 is just 1, it's 0. So after some simplification, we get the final answer of 2 ln 2 minus 3/4. That's for today.